Vaishakhi Shah from LG Institute of Engineering and Technology. If you remember then, in our last lecture, in your subject Fluid Mechanics and Hydraulics, we solved some examples based on vertically immersed body in a liquid. Now, today we will see another theory to find out total pressure and center of pressure for inclined surface. So let's start with this theory. Now, your title of the theory is Inclined Plane Surface Submerged in the Liquid. In last lecture, we derived the theory where your surface is vertically submerged in a liquid. But today, your object or your surface is submerged in a liquid but inclined at some angle, inclinedly immersed in a liquid. So here we are considering an inclined surface of arbitrary shape immersed in a liquid such way that surface makes an angle theta with free water surface. So here there is your diagram for the immersed surface. This is your arbitrary surface which is immersed inclined in the body. As you can see that this is your free surface of the liquid which is horizontal, and your immersed surface is inclined. At which angle? At angle theta. That angle is your angle theta. Okay. Here in the body there are 2 points, where first point is G. G point is called center of gravity and second point is P. So P point is called center of pressure. Okay. G center of gravity and P center of pressure. There are 2 points here. Here above is your free surface of the liquid. Now this object is at angle theta. If we are taking projection here, then the distance of center of gravity and free surface of the liquid is h bar. Taking projection of entire object on that inclined plane. So taking projection, the distance of center of gravity to free surface of the liquid is h bar. Same way, distance of center of pressure from free surface of the liquid is h star. Remember that here we are taking projection of that body on inclined plane, and we are measuring distance of inclined plane to free water surface. Okay. Now here we are considering a small strip. So a strip, area of strip is dA and distance of strip from free surface of the liquid is small h. Distance of strip from free surface of the liquid is small h. Okay. Now the next part in this theory or in this derivation is this OO axis. As you can see this axis which is indicated as OO axis. Then OO axis, here the distance of OO axis with center of gravity is indicated as y bar. Y bar. The distance of center of pressure from OO axis is indicated as y star, which are indicated from here y star and y bar. And distance of strip, these are the horizontal distances, and distance of strip from OO axis is y, small y. Okay. So here there are 6 distances from free surface to subject, that is h star and h bar and y star, and from O axis y bar and y star. Here, so again here if we are considering this triangle, this side, vertical side of triangle is h star and this inclined length of triangle is y star. Y star. And if we are applying equation for sine star. H star and Y star both are clearly shown in your figure. Sin theta equals to H star upon Y star. Okay, that is your enlarged section. Now same way, if this is your second triangle and this vertical distance is H bar and inclined length is Y bar. If you apply the equation for sin theta, then sin theta for this triangle is H bar upon Y bar. Clear? Okay. So clearly it is shown in your diagram that theta is your angle. So sin theta equals to H bar upon Y. Okay. Now third. This is your third triangle where vertical length is H and this inclined length is Y. And if we apply equation for sin theta here, then sin theta equals to H upon Y. Clear? This equations for sin theta we will use in our remaining derivation. Okay? So let's start our derivation here. Again, this is diagram for inclined immersed body where capital A is area of inclined body. Theta is the angle at which immersed surface is inclined with a free surface. Immersed surface is inclined. If this is your free surface, then angle between these two is theta. G is center of gravity. T is center of pressure. Now Y bar is the distance of CG from O axis. Y star, distance of CP. CP is your center of pressure. Distance of CP from O axis. And H, that is depth of small strip from free surface of the liquid. Here H bar, that is depth of CG from free surface of the liquid. And H star is the depth of CP from free surface of the liquid. Yeah. Now, again this is your inclined immersed surface. First step we have to find out total pressure force, which we indicate as F. Okay. If you remember then, for vertically immersed body, the equation for total pressure force was F equals to rho G H bar into A. Now we are finding out the total pressure force equation for immersed body, for inclined immersed body. Okay. So for that, here we are considering a small strip of area dA, depth H from the free surface of the liquid. We are taking a small strip. The area of single strip is dA and distance from free surface is small h. And distance y from O axis. Now, the total pressure force on acting on the strip is indicated as dF. Now, dF is your pressure force on strip. Force equals to pressure into area. Pressure on strip is P and area of strip is dA. So, dF equals to P into dA. Here we know that P, that is rho G H. P equals to rho G H and dA is your area. As we know that sin theta equals to H upon Y. Sin theta, if you apply equation for sin theta in diagram, then sin theta equals to H upon Y. So what is equation for H? Yes, H equals to Y sin theta. H equals to Y sin theta. So here replace in rho G H, replace H by Y sin theta. So here P equals to rho G Y sin theta. So pressure on single strip, that is dF. dF equals to P into dA. We replaced P by rho G Y sin theta because H equals to Y sin theta into dA. Now, total pressure force on entire surface. dF is a force on single strip. Now, total pressure force on entire surface is F equals to integration of dF. You can find out total pressure force by integrating force on single strip. So integration of dF, we know the equation for dF here, which is rho g y sin theta into dA. Now rho g sin theta, that is your constant. So rho g y sin theta into integration y into dA. Now integration y dA equals to y bar into a, because integration y dA, that is moment of area about OO axis. Moment about OO axis. So you can replace integration y dA with y bar into a. So your equation for F becomes rho g sin theta into y bar into a. Now if I ask what is y bar sin theta here? If I have to replace with something, then what is y bar sin theta here? Y bar sin theta. Sin theta equals to h bar upon y bar. So y bar equals to h bar upon sin theta. Y bar equals to h bar upon sin theta. If we are placing this equation in F, so h bar, you get F equals to sin theta cancel. So F equals to rho g h bar into a. Rho g h bar. What is F? Total pressure force. So here total pressure force for surface immersed inclined, equation is rho g h bar into a. Rho is density of fluid, g is acceleration due to gravity, h bar is distance of CG from free surface, and area, capital A, that is your area. This equation is same as equation for vertically immersed surface. So for both the cases, equation to find out total pressure force, either vertical immersed body or inclined immersed body. Equation for total pressure force is same, which is F equals to rho g h bar into a. Okay. Now in our second part, we will find out center of pressure, which is H star. Okay. Again, this is your diagram of immersed body, inclinedly immersed body. We have to find out H star, distance of CP from free surface of the liquid. So pressure on force on single strip is dF. We derived earlier that dF equals to P into dA. Now P into dA, which is rho g y sin theta into dA. Now moment of dF. dF is a pressure on single strip. Moment of single strip about OO axis. OO axis. So moment of strip about OO axis. Moment that is force into perpendicular distance. Now force on single strip is dF, and the perpendicular distance from OO axis, which is y. That moment is dF into y. Okay. Now we know the equation for dF, rho g y sin theta into dA into dy. Okay. Sorry, y. So equation becomes rho g sin theta into y square into dA. Y square into dA. Now summation of moment of pressure about axis OO. Summation of moment of total pressure force about OO axis. Then to find out summation of the moment, you have to take integration. So integrating rho g sin theta y square into dA. Here y square into dA, which is your second moment of inertia, and you can replace it by I0. So integration y square into dA, that is I0, second moment of inertia about OO axis. So your equation becomes rho g sin theta integration y square dA replaced by I0. So rho g sine theta I0. This is your equation number 1. Now moment of total pressure force F about OO axis. Now the total pressure force is acting from center of pressure and distance of center of pressure from OO axis is y star. So moment of dF about OO axis, which is F into y star. This is your equation number 2. Okay. Now equating equation number 1 and 2, you get that F into y star equals to rho g sine theta into I0. Okay. Making y star as your subject, then y star equals to rho g sine theta I0 divided by F. Now F is total pressure force and here, F is total pressure force and again, what is y star? H star upon sine theta. So replace the y star with h star upon sine theta and we know the equation for F, rho g h bar into A. So placing the equation, you get y star, that is h star upon sine theta, equals to rho g sine theta I0 upon rho g h bar into A. Clear? So by equating or by rearranging, you get h star equals to sine square theta upon ah bar plus I0, and this is your equation number 2. Equation is in form of h star and we have to find out h star, that is location of center of pressure from free surface. Okay. Now by parallel axis theorem, we know that I0 equals to Ig plus Ay bar square by parallel axis theorem. So y bar, as we know that y bar equals to h bar upon sine theta. So I0 equals to Ig plus Ah bar square upon sine square theta. We replaced y bar with h bar upon sine theta. So substituting the value of I0 in equation number 3. This was your equation number 3, where h star equals to sine square theta upon ah bar plus I0. Now placing the equation of I0 in equation number 3. So h star equals to sine square theta. By rearranging the terms, you get h star equals to sine square theta upon ah bar plus Ig plus into Ig plus ah bar square upon sine square theta. So your final equation for h star is Ig sine square theta upon ah bar plus h bar, where h star is the distance between center of pressure to free surface of the liquid. H bar is distance of center of gravity from free surface of the liquid. Ig, that is your moment of inertia. Theta is angle of inclination from free surface to inclined plane. And capital A, that is area of your entire body. So you can find out location of center of pressure by using this equation of H star. Okay. So done for today. In today's lecture, we derived two equations. Where first equation is for total pressure force for immersed body which is inclined, and the second force is also for location of center of pressure for inclined body. Okay. Now in next lecture we will solve some examples based on this theory. Thank you.